Good morning, everyone, and welcome to another episode of Math and Silly Hats. Today we're going to be looking at identifying solutions to two-step linear inequalities with one variable. Now, when ALEKS presents us with these problems, it's going to ask us to determine whether or not a bunch of inputs are solutions to the inequality. That means, do they make the inequality true? There are a couple of different approaches we can use to solve this. We can either substitute all of those inputs they give us into the inequality and see if they're true, or what I would recommend is we could simplify this inequality. In other words, get all the variables by themselves and all the constants on the other side, and then it'll become very apparent whether or not each of those inputs works. Let's try both for our problem. First, we're going to use the substitute and check method. We're going to substitute all those values of w into this inequality and see which one of those are true. Now this will take a bit, so let's use some magic. Amazing! Anyhow, this does take a little bit more time because we have to rewrite this inequality with each of the different inputs we want to substitute for our possible solution and see if it's true for that inequality. So let's simplify. First, we're using order of operations. We're going to say 5 times negative 8 is negative 40, plus 2 is going to be negative 38. So is negative 38 less than 32? In this case, yes. We know that certainly any negative number is going to be less than a positive number, so that holds true. We're going to do the same thing for each of these other possible solutions, each time simplifying by first multiplying the value we substituted in that could be a solution by 5, adding 2, and seeing if that's true for our inequality. So 5 times 10 is 50, plus 2 is going to be 52. Is 52 greater than 32? Well, in this case, that's certainly not. Next, 5 times 0 is 0, plus 2 is going to be 2. Is that less than cat? Next, 5 times 0 is 0, plus 2 is 2, and 2 is certainly less than 32. So that will be a solution. And then finally, 5 times 6 is 30, plus 2 is going to be 32. Now 32 is equal to, but not less than, 32. And since our inequality is a strictly less than symbol, this is also not a solution. You can see this requires a little bit more work and would require even more work if they gave us more values that could be solutions. So let's try it the other way. Let's try it by simplifying this inequality. So what I'm going to do is I'm going to use algebra to rewrite this inequality in terms of w. So if I've got 2 plus 5w is less than 32, the first thing I'd like to do is get all the constants over here. So I'm going to subtract 2 from both sides to move all the constants to the right side. That'll leave us with 5w is less than 30. Now, I'd like to get that variable by itself. It's being multiplied by 5 currently, so let's divide each side by 5. That leaves us with w is less than 6. This means that any value less than 6 will be a solution to the inequality 2 plus 5w is less than 32. Now this looks a lot simpler, right? And it is a lot simpler because if we just run our different inputs, negative 8, 0, 6, and 10, we just ask, is each of these less than negative 6? Well, when w is negative 8, that's certainly less than 6. 0 is certainly less than 6. 6 is not less than 6, it is 6. And then 10 is not less than 6. So we can easily see our solutions, even if given a greater bank of them, by simplifying our inequality. So let's put those into ALEKS. We said that negative 8 is a solution, 10 is not, 0 is a solution, and 6 is not. So whether you chose to substitute and check each of the possible solutions, or whether you chose to simplify your inequality and then run each of these possible solutions through a simpler version of the inequality, hopefully you got the same solution as me. Hope you have a great day, everybody. Bye-bye!